Good morning, dear students. I am Dr. Batini Srinivas, Professor of Chemistry in St. Peter's Engineering College. Today, I am going to discuss about the band structure of solids and types of materials. What is the topic today? Band structure of solids. Band structure of solids and types of materials. Try to finish this topic. So before going to discuss what I explained the last videos, we have completed the linear combination of atomic orbitals, energy levels for diatomic molecules such as nitrogen, oxygen, fluorine, and crystal field theory postulates and how to form the crystal field theory in tetroidal complex and octoidal complexes and square planar complexes. These are we have completed till now. Today we will discuss the band structure of solids. So what is meant by band structure? Where you want to study this theory? And what are the uses of this theory? Why we need? Just think it, okay? This is the quantum mechanical treatment of metallic bond and similar to molecular orbital approach of a covalent bond. Metallic means quantum mechanical treatment of metallic bond. Unlike simple covalent molecules during the formation of metallic crystals. So that metallic crystals mean the molecules mean a very large number of atoms, almost in order of 10 power 23 molecules, large number of molecules, a very large number of atoms in order to 10 power 23 or more are brought together. More number of atoms are brought together and their atomic orbitals undergo which combination? Linear combination. This is we have discussed in LCAO orbitals, linear combination of atomic orbitals. In large number of atoms. So they are brought together and the atomic orbitals undergo linear combination to form an exactly same number of molecular orbitals. The energy of these molecular orbitals are so close spaced, very close spaced, that they appear to be continuum, known as quasi-continuous energy band. Mean very close, mean the band is like this. Mean this is called what? Quasi-continuous band. Mean continue. The band is called the quasi-continuous energy band. What is the bond? Quasi-continuous energy band. Okay? Hence, this theory called as what? The band theory. We can say the band theory. This band structure of solid also called as the band theory. We can say band theory. What is the band theory? Or band structure of same. The description of solids, we can say. So once again listen. The quasi-continuous energy band formation takes place in the solids. So that is the reason what we say quasi-continuous band. Hence named this theory band theory. So we can say the band theory. What is the meaning band theory or band structure of solids? Just say. Okay. The molecular orbitals formed. This molecular are delocalized. What is that? The pi structures are the delocalized. that belongs to the crystal size of all crystals. All crystals, as a whole crystals. And how to form the progressive formation of a quasi-band, I will draw it. I will show it in the diagram. So let's look the diagram. So in the diagram, before going to diagram, so we have to know the orbitals, atomic level orbitals, before going to the quasi continuous energy band. So atomic orbitals we have to see. In the atomic orbital already we studied in the diatom molecules. So bonding, anti-bonding, non-bonding and bonding. So these are bonding, anti-bonding already in the first class, that is especially in the energy level diagrams of diatom molecules, we have already seen that one. Okay, so in the two atomic orbitals, the band is like this. The band is, how many is there? Bonding orbitals and anti-bonding orbitals. What is that? Bonding orbitals and anti-bonding bonding and anti-bonding. Just write the bonding and anti-bonding. Bonding and anti-bonding. And three atomic orbitals. In three atomic orbitals. Here one more anti-bonding, bonding, and third one is the non-bonding. The formation takes like this: 2 atomic orbital, 3 atomic orbitals, and 4 atomic orbitals. Atomic orbitals. Anti-bonding, bonding, anti-bonding, like this. So n number of orbitals, 2 atomic orbital, 3 atomic orbital, n number of atomic orbitals, n number of atomic orbitals. So form like here. I will draw here this one, n number of atomic orbitals. Is the band. This band is called the quasi-continuous energy band. What is the band? This is a quasi-continuous. First 2 atomic orbital, 3 atomic orbital, 4 atomic orbitals. Then like that, n number of atoms continuously. It's a continuously formation takes place in the metals. In the metals or any other solids. In the solids, like this band formation takes place. This band is called what? Quasi-continuous band. And this band energy also called as a quasi-continuous energy band. Understand? Please draw the diagram. This is called what? Quasi-continuous energy band. Okay? So let's look one example. After this, we have to see the one diagram, because this is the formation molecular orbitals in metals. Any example, for example, the best example is the lithium metal. Okay, so it is a small atom. We have to look the lithium metal. Okay. So in the lithium metal, many electrons are there in lithium metal? Only 3 electrons. What is the configuration? 1s2, 2s1 and 2p0. This is the 1s level. In 2p level, one off filled and another one is the vacant. In the 1s level, that is completely filled. This is about the electron configuration of lithium. Okay, first before going to see this one in the lithium metal, so I will draw the one diagram. So we have to see this diagram and draw it. It's a very, very important. So in the lithium metal, so how many is there in this? 1s, 2s and 2p. Mean we can say 1s band, 2s band and 2p band. So how it is there? 1s level is the completely filled and 2s is the off filled and 2p is the vacant, 0. So that is we have to write in the form of diagram. Okay, that is the what diagram? Energy level diagram. Okay, energy level diagram. This is the energy level diagram. In the 1s, what is? It is a completely bond. So that is here. This is the 1s band. You can say 1s band. So it is completely filled. Because completely filled, 1s band. So completely filled. 1s band is a completely filled. Completely filled. Completely filled. Because this orbital is completely filled. In 2s orbital, the second orbital, it is what? Off filled. So 2s1 off filled. So let's see this. So here this band is off filled. Off filled. Off filled. And the third one is the 2p band. 2p band with 2s band. Here, this is completely vacant. So vacant, be 0. There is no electrons. Okay, here the pink color, it is an off filled. Off filled. This is vacant. Vacant orbitals and off filled orbitals and completely orbitals. Here this is the overlapping zone. This overlapping zone. So this is called the forbidden zone. This is so understood this one. So what is here in 1s band is that orbital is completely filled. Okay, in 2s band here the off filled the pink color, only off. This is the another off. Okay, up to here we can see off field. Then 2p, that is a completely vacant, and 2p and 2s is overlapped. So this is called the overlap zone. So it is a vacant. Okay, this is an overlap zone. Okay, and this is an off-field 2s orbital, and this is the forbidden zone, and this is the completely field. Okay, please write. It is an important diagram. So I will tell you one by one once again. Okay, in the 1s band, let's look in the 1s band. 1s band. What is this? This band is formed by the combination of large n number of atomic orbitals. Atomic orbital? 1s atomic orbitals. 1s atomic orbitals. Large number of, because the band theory means 10 power 23 atoms. So large number of atoms, n number of atoms. We can say n number of atoms of lithium atoms, and hence contains the n number of energy levels. N number of, so we can't count it. N number of. So this band is filled, that carries the 2n electrons. This is actually inertial, already the inertial band, and is not influenced by the surrounding atoms. There is a surrounding atoms here, so it's not influenced any surrounding. Therefore, narrow equilibrium in interatomic distance. What is that? Narrow equilibrium. Equilibrium is very narrow, and interatomic distance equilibrium. Okay, I think equilibrium interatomic distance. So this is it's not influenced by any surrounding. Means the gap is there. 1s and 2s. One gap is there. This is called the forbidden zone. We can say the forbidden zone. Now we get 2s band. What is the 2s band? This band is formed by the, it is also combination of 2s, n number of 2s. Orbitals of n number of atoms of 2s. 2s orbitals, it is n number of atoms, and this band is off field, contains the n number of electrons, and the lower half is filled here. What is the lower half is filled, while the upper one is the vacant. This is the upper one. So here the upper part is the vacant and lower part is the filled, off filled. Lower part is filled and upper part is the and vacant. So this is 1s and 2s. The electrons can mean here the valency. Here the valency bond. 2s means one electron is there. This is the valence electron. We can say valence. This is the valency band, while the upper half remains vacant. So this is a valency band and significantly influenced by the nearest one, because the same level is there, the 2s and 2. So it is very near to the surrounding. The 2p orbitals are very near. 1s is another orbital. It's not near. That's the reason these electrons can move to energy levels in the upper half of the atom temperature. At a room temperature, the electrons can move to energy levels in the upper half of the atom. Mean the electrons goes like this and this. Understand once again? What is that? This is the valency band and significantly influenced by surrounding atoms. The electrons can move to energy levels in the upper half at room temperature. At room temperature. That is about the 2s level. Mean 2s level is a completely, so off field and lower is the off field and the upper is the vacant. And at room temperature, it may chances to the valency electron chances to jump on the orbital or same orbital. Another. Okay, that is the reason this is the very close. That is called the overlapping zone. We can say overlapping zone. And finally, 2p band. We can say 2p band. That 2p band here also n number of atoms of lithium gives 3n levels, the 2p band. 2s and 2p levels are very so close in energy that the bands overlap, because here the band is overlap. The band overlap, and the electrons of 2s band get additional energy levels of differing slightly in energy to move about. Mean energy we have to take in that they can move differently. The energy levels differing slightly in energies to move about. The total capacity of this is the almost is the 8, and so here how much 1 by 8 is free. So total is here. The total is the total capacity of this overlap band is 8 n electrons. 8 n electrons. N electrons is 8. So therefore the 1 by 8 is field. 1 by 8 is the field. This is about the bands. It's the best example of lithium metals. Lithium is the example. So we have tried. This is the 1s band, 2s band, 2p band. 1s band is a completely filled, and 2s band is a half filled. Lower part is a half filled, and upper part is a vacant, and 2p is a completely vacant, and 2p and 2s are overlapped together. This is called the overlap zone, and this is the half filled, and the 2s and 2p, the gap is there. This is the here it is not the 2s 1s band is not influenced by any surrounding atoms. That is the reason this is the forbidden zone, meaning the gap is more. This is about the lithium. Okay, so now please note down this one. It is important. It is important diagram. Now, types of material. So, how many types are there? So, what are the classification of materials? Okay, is just within 5 minutes we will complete this one. Just what is that? The materials are classified into 3 types, depending upon the energy gap. Just we have seen the energy gap between the valency and conduction. What is that? Valence. Valence band and conduction. It's a conduction band. Okay. So here the depending between the valence and conduction bands. Valence and conduction. Valence band and conduction bands. Just before we have seen the bands. So here that they are actually the first one is insulators. What are that? The first one is there are 3 types actually. There are the 3 types. The first one is what? Insulators. And the second one is the semiconductors, and third one is the conductors. 3 types are there: insulators, semiconductors, and conductors. So can you look at the diagram? That diagram is important. So here, because the band theory, we have seen the band theory. So what is here? The energy diagram. We will look the energy diagram. The energy diagram. I will write the curve energy diagram. Okay. So before going to discuss the how many types are there are 3 types of conductors: insulator, semiconductors, and conductors. So the energy level. So the band between the valence band and conduction band. We have to remember the conduction band and valence band. So valence band is a common in all three types. The gap between the conduction and valence band is important. The band, so that is called about Fermi gap. What is the gap? The Fermi level in gap. You can see the Fermi gap. That Fermi is the important one. Fermi gap. Okay. Now, so here in energy, the first one is the band. Yeah, like a bands. This is the valence band. You can see what? Valence band. Valence band. And this is the conduction band. Conduction band. Valence band and conduction band. So this gap, Fermi level, we can say Fermi level gap. So the gap is very high. So this is in insulator. You can say insulator. This is appear in where? In insulators. Insulator. And in semiconductors, you can semiconductors. This is the valence band. This is the Fermi gap. This is the semiconductors, conductors and conductors. Okay, this is about the. So there is no Fermi gap in this in conductors. Here the little Fermi gap is there. Here the large Fermi conductors are there. Okay. So how many types of materials are? Three types. Insulators, semiconductors and conductors. So in insulators, best examples are non-metals like wood, plastics. These are the. So here that there is a large band gap is there between the filled valence bands and valence. Valence band is empty and filled one. This is an empty. Yellow color is an empty band. Okay, so this is the blue color is the filled one. The gap between the filled valence band and empty conduction bands. Therefore, the electrons cannot be promoted because the large band is there. So valence band to conduction band. So freely they cannot move freely from the valence band. So here the insulators, the electrons cannot move freely. They cannot move freely. So that is the reason here that there is no formation. Because the reason Fermi gap is very. And in the case of semiconductors, what happens in semiconductors? There is a small gap here the small gap between the filled valence band and empty conduction band. So mean the conduction band with the rise in the temperature or by adding any dopant, so they can move. The electrons can move if temperature increase the temperature or any adding the dopant. Dopant means impurity. So when we add the dopant or temperature, the electrons can move chances because the gap is very less. The small gap between the valence band and the conduction band. This is the valence band and this is the conduction band. So we can say conduction band. Conduction band. This is the conduction band and this is the valence band. The conduction band and the valence band. So if you can rise the temperature or by adding the temperature, what happens? Then the electrons jump into the conduction band. So this is about the semiconductors. In semiconductors, tomorrow I will tell you that very clearly. So dopants mean adding of a dopant or increase the temperature. So they are active the semiconductors. And finally the conductors. In conductors mean the valence band and the conduction band overlap here. Overlap. There is no gap. There is no gap between the valence band and conduction band. So there is no band gap. So therefore the electrons can move freely. Electrons can move freely. There is no gap. Here little gap is there. We can add the temperature or add the dopant. Here a large gap is there. Electrons cannot move. So electrons cannot move means that is the insulators. So if we are adding the temperature or adding the dopant, increase the temperature, then the semiconductors are here the valence band mean there is freely moving electrons from valence band to conduction band. So this is the about types of materials. 3 types of materials. Band structure of lithium, 1s orbital, 2s orbital, 2p orbitals. That is the 1s band, 2s band and 2p band in the band structure. Whereas in the types of material, there are the 3 types of materials: insulators, conductors and semiconductors. Okay, this is the today's class. Okay, tomorrow we will see on the topic that is the doping, effects of doping on conductance. Okay, thank you.